In the previous video, we talked about microservices while developing an application. One of the ways these services communicate is through REST APIs. In this video, we are going to talk about those REST APIs. What are these APIs? So let's move ahead and see what's the agenda for the today. First, we will be talking about web services, as REST is one of the web service. Other is SOAP, SOAP. And then what is REST? Then we will talk about REST architectural properties. Then we will talk about constraints. Then what are HTTP methods? So this is quite theoretical video will be. I know it's boring, but let's stick to it because basics are necessary. Then in next video we will we will jump into the practical one. We will see how to design and we will design a microservice and see how do they interact. So for 5-10 minutes, let's stick to it and see the theory part. So what are web services? So web services are they use web technologies such as HTTP, originally designed for human to machine interaction. Communication is utilized for machine to machine communication. What does it mean? Human to machine means you uh, give request through browsers in your machine, in your computer system to servers, and they respond to that browser, and you see the screen, you see the response in static HTML pages there in your browser. So that means human to machine interaction. But it happens that when one part of your application needs some output from other application which is at some other place in the world, so it means machine to machine communication. So web services facilitate that part, that machine to machine communication, when one application is needing the output from other service based on the input that it is giving. So more specifically for transferring machine readable files format such as XML or JSON, so they communicate through a well defined format which is XML and JSON. So web services commonly provides a web-based interface, right, to a database server which are utilized by another web server or by a mobile app that provides a user interface to the end user. So before the actual service coming to end user, different systems communicate among themselves through web services. So REST, what is REST? REST is one of the web service that is there, which with the help of which different systems communicate. Its full form is representational state transfer. This is a software architecture style that defines a set of constraints to be used for creating web service. Okay, so this provides interoperability between computer system on the internet, that we talked about, the communication between different services, different components over the internet. So there is no official standard for RESTful web API, so there is good thing, there are no rules that you need to remember on. So you just go on, you know some language and you know some framework, go ahead and develop it. Just make sure that it is accepting some input and giving output in well suited formats like XML or JSON. That's it. There is no official rule. So the REST was first introduced by Roy Fielding in 2000. He talked about it. He put up the idea about microservices. Uh, Not microservices. He put up the idea about REST. So RESTful API is defined with some stuffs, with some properties. So it has a base URL which is defined like this. It looks like a normal URL, website URL that you put in your browser. HTTP methods, what do you want to do? You want to get something, put, post, delete, patch. We will see details of these methods in a while. A media type means what media type you want to communicate with, what input it is expecting, and what output it will respond. So that is media type that it will give. So these are the three properties only that you should provide, you should be taking care: base URI, HTTP methods, and a media type. So this is the REST client that is requesting for some response based on the request that it is giving. So request can be of type get, put, post, delete, all these. And so it is internally communicating, internally processing that request, REST request handler, which is passing the request to service handler, and then it is talking to the database handler, and which subsequently talks to database and prepares the response and gives it to the client in format of JSON or XML. So XMLs are popular communication channels, communication not channels but formats on which data transfer happens. Okay, so some architectural properties. Performance should be quite high in component interactions. The different components should be scalable. Okay, so if one component demand is there, so that should be scalable. Large number of components and interaction among components. So simplicity means there should be a uniform interface. Modifiability of components to meet changing needs. So it should be very easy to make the changes in your component. Visibility of communication between components by service agent. So they should be able to communicate each other, because there is no point if they are not able to respond to the request. Portability. So code should be in such a way that it should be movable with the data. So portability should be a feature. Reliability. So if there are system failures, so it should show some kind of resiliency towards the failure. After properties, let's see some constraints. There are some constraints which should be in your service to be able to be called for a REST service. Okay, so restricts the ways that server can process and respond to the client request. Okay, if a system violates any of the required constraints, it cannot be RESTful. So these are just constraints that we talked about. These are not rules, but these are the steps that mandatory with the service. Client service architecture, they are basically there for separation of concerns, what client should do, what server should do. Statelessness. Statelessness means no client context being stored on the servers between requests. So there is no session kind of thing. When one request is going with some set of input to the server, to the service, it should respond with some output. But independent, it should not store anything about that request. It means if that request is going to the service 1,000 times, so it should return with the same output, right? So data can change based on the input, but it is same, so output must be same always. Cacheability, so the response as the other stuffs, it should be cacheable for performance, to improve the performance. Layered system, a client cannot tell whether it is connected directly to the end server. There will be a client server context. There should be separation of concerns, and client should not be able to tell that whether it is communicating with the machine. It is actually where the all the stuffs are there, so it should not be able to tell that. It should be an internal stuff. So layered system should be code on demand. So that changes we talked about, that is optional for the constraints. Uniform interface. Uniform interface is mandatory. It simplifies and decouples the architecture, which enables each part to evolve independently. So first is request identification. Request So the request that you are giving, so it should be identifiable with some base URL that we talked about. So resource manipulation through representations. So request that it is giving, it should have some body and some data with which it will manipulate the data and prepare the response. Self-descriptive messages, the request that you are sending, it should have all the information to describe that message in full context. Hypermedia as the engine of application states. So you should not remember the services that a particular service is providing. So if you are hitting for one request, it should be responding all the available options, all the services that it is providing. So that comes under hit OS. Hypermedia as the engine of application state. Hypermedia as the engine of application state. So it should be responding with all other available options that it can offer. So it was about architectural constraints. So let's moving ahead. HTTP methods. We will talk about. Say we saw this is get, post, delete, patch, all the methods, and this is URI that a request can happen with this URIs. So just go ahead and let's quickly finish this. Okay, so what does get does? It is read only type. So it retrieves the URI of a member resource, of collection resource in the response body. It is same for this URI. Difference is it is talking about a particular item only. What post does? It creates a member resource in the collection resource using the interactions in the request body. Put, it updates the existing data that is there. It replaces all the representation of the member resource of the collection resource. Whatever in collection, it updates that one. So patch, it updates all the representation of the member resources of a collection resource using the instruction in the request body, or may create the collection resource if it does not exist. So put and patch are somewhat same, but there is a thin line that is different. So delete, as name suggests, it deletes all the representation of the member resource of the collection resource that is there. Okay. So it was about the HTTP methods. So some more features about HTTP methods. Get is read only. Put, post, delete are idempotent. What it means idempotent? So meaning that applying the multiple times to a resource result in the same state change of the resource as applying them once, that we talked about. Only first request or thousands of requests, the state change should be same with the same requests with same input. So the response is different. The response can be different, but state change must be same. Get and post methods, they are cacheable, they can be cached. Unlike SOAP, which is another web service, there is no official standard for RESTful web services that we already see. This is because REST is an architectural style while SOAP is a protocol. SOAP is a protocol, but REST is an style for the architecture of application. So REST is not a standard in itself, but RESTful implementation makes use of standards such as HTTP, which is for the communication over the internet, HTTP protocol, URI, Uniform Resource Interface, JSON, and XML. It makes use of these technologies. This was all about RESTful API web services. So there are many whole stuffs that you can read about this. So I had taken just one reference, Wikipedia. You can go ahead and explore more about REST APIs, but this was the basic idea that we are going to see, that we saw. Okay, so what next? Next we will be images, Google search just. Next we will be building an RESTful service, which is a microservice, with the help of Spring Boot technology. We will be using Java as a programming language, and then going ahead we will be using Kotlin also to develop microservice. So stay tuned to the lesson channel and I'll see you in the next video, which is not a theory. Okay, it will be interactive and you will see the microservice in action. So see you in the next video, guys. Bye bye.